Algebra 2, Chapter 5.4, Exercises 1 through 12. I'm going to go over the odd number problems in this set, and before doing so, I want to go ahead and look at these symbols. This symbol here, which is less than or equal to, when we graph linear inequalities, I want to change this to say, instead of less than or equal to, we'll say not equal to and less than. Just put less. And likewise, if we have this less than or equal to, we will write this as equal to and less than. And the reason for that should be clear as we go through these exercises. I'm going to be changing pens quite a bit. So this problem 1, we have y is equal to and greater than. Well, equal to means we draw a solid boundary line. And we have this, it's just like you draw a line. And in my Algebra 2 classes, I have a song, where do I start my line? Find the Y-intercept, which is -4, and things will be fine. You need to find your points one by one. So you use the slope, it's rise over run, and that's rise over run, 1/2. So we go up 1, or these are actually by 2, but proportionality is the same. So we can go up 1, rid over 2, up 1/2. So it'll be this, and I like to just draw the dots and just kind of draw a line. Now I'm doing it freehand here on this glitchy tool. That's not so bad. And equal to and greater than. So I'm going to put a little up arrow here indicating greater than. So our solution set based on this first inequality is above the boundary line and including. And now we have the second inequality, y is equal to and less than 5x plus 5. And for that, I'm going to change color code. I'm going to go to a red one, and we have our y-intercept is 5, so we go up to 5, and our rise over run is -5, so we can go down 5 over 1. So that's what that looks like. Down 5 over 1. Next is down 5 over 1. Down 5 over 1. So quite a steep, negatively sloped line. Then we come up here, so it looks like this, very steep. And again, it's equal to and less than, so I'm going to go like this. Okay, it's a little bit crooked there. And less than, so we're going to go down below here. And the area that these two sections have in common is this right here. I'm just putting this in green. So this whole area, so we separate into essentially 4 quadrants. So above the blue line, below the red line, and last thing says give the coordinates of 2 points in the solution set. So if we go to, we'll put -8, 4. So -8, 4. That's 1 point, and another one, the solution set, will be this one right over here, -2, 8. So -2, 8. Okay, let's go on to the next odd number problem, 3. In this case, we have an equation. We have two inequalities in standard form, and we really have a choice in this instance. There's an intercept method you can use, but for the sake of consistency, I'm going to go to the slope-intercept form. So I'm going to rewrite x minus y is greater than 2, and then if we solve for y on the left side, we subtract x. So we have negative y is greater than 2 minus x, and now if we divide this whole equation by -1, we're going to have y. Now, we divided by a negative number, so that means we have to change the direction of our inequality. So we have y is not equal to and less than, instead of 2 minus x, x minus 2, or you could say -2 plus x. So that's going to be our first inequality. And we say less than and, less, not equal to and less than. So I'm going to go to my dashed line here. And we have our y-intercept is going to be -2. So I mark that. And our slope is going to be 1, so that's up 1 over 1. So it's going to be this type of not equal to. So you're drawing a dashed line. Kind of shaky, but that'll work well enough. And not equal to, but less than. So what I'm going to do for that is draw below, indicating less than. Oops, I meant to get a, there we go. I meant to get a solid line. Okay, so there we have it. That's what that inequality looks like. And now we're going to take this 2x plus 3y is equal to and less than 4. So I'm going to take, get a red pen here. So I'm going to write, just work to the right here, 2x plus 3y is less than or equal to 4. And now if we subtract 2x, we have 3y is less than or equal to 4 minus 2x. And now dividing by 3, so we get y is less than or equal to, and I'm going to switch the order to get in slope-intercept form. I put negative 2x over 3 plus 4/3. And our y-intercept is 4/3, which is going to be, these are by 2. 4/3 is a little bigger than 1. So I'm going to go right up here, just a little over halfway. And our slope is -2 over 3. So we can go down to, so I'm going down to, and 3 to the right. So it'll look like this. And then I'm going to go the opposite direction, up 2 and 3 to the left. And we have equal to and less than, so that'll look like, be a line like this. That's not so bad. And less than, so we're going down below. So that means below, what do these have in common? Well, it's going to be this area right here. So I'm going to go get any green one. So this area right here I'm shading in. And the last thing it says is find 2 points on here. So we'll put this point here, which is 2 comma -8, and then also this point right here is going to be, looks like 6 comma -4. Those are 2 points within our solution set. Next, on our problem 5, we have y is equal to and less than 2x plus 5, and y is equal to and greater than 2x minus 5. Well, we can just find the y-intercept right off the bat for this one. We go up to +5, and we have 2x, which is 2 over 1, so 2 over 1, so we go up 2 over 1. In the opposite way, we're going to go down to 1 to the left, down to 1 to the left, down to 1 to the left. So it's going to look like this. Again, solid line. There we go. Pretty good. And then we're less than. So there we go, drawing arrow below. And the next one we have is the y is equal to and greater than 2x minus 5. You should be able to see where this is going already, I hope. So we go to the -5 y-intercept, and then we go to, we have 2 over 1, same as above, so we go up 2 over 1, up 2 over 1. Looking like this, find up 2 over 1. So we're going like this. So what we have is 2 parallel lines, and we are greater than. So what is our solution set? Well, instead of separating the solution set in quarters, what we're doing is we're going in between these 2 parallel lines. And that is our solution set. And what are going to be 2 coordinates that go inside the solution set? Well, the origin, 0, 0, is in the solution set. And also, let's take this point up here, which is 4, 8. Okay, so that's that one. Let's go on to the next other problem, which is 7. We have y is equal to and greater than 2x plus -2x plus 2. And then this other one here, down below, we have 2x plus y is less than 10. So if we subtract 2x, we have y is less than, not equal to and less than. We have -2x plus 10. Okay, I'm going to do this first one up here. We go to the y-intercept first, 2, and then we have -2 is our slope, and that's going to be down 2 over 1, so down 2 over 1, down 2 over 1, down 2 over 1. So it'll be like this. So our y-intercept of 2, coming down below, and equal to and greater than, so we're going to be going up above here. And next, I'm going to get our red line, but also it's not equal to, so I'm going to make this red dashed line not equal to less than 2x plus 10. Two x plus 10. Right up here. Down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. So it's going to be this thing right here. This one's a dashed line. And again, we're going down, so we are between the two parallel lines in this instance. So possible solutions here would be 6 comma negative 6. I'll write that 6 comma negative 6. That's one solution. And then up here at the intercept, y-intercept, or along the y-axis, we have 0 comma 6. This will be part of the solution set. So again, we are between the two parallel lines in our solution set. So that all checks out. Okay, let's go on to 9. We have y is equal to but less than 1/2 x minus 4. So for that, we go to our y-intercept of negative 4. So there it is. And we have 1/2. So that's rise over run of 1 over 2. So we go up 1 over 2, up 1 over 2, and then the other direction, like this. So we're going to go like this. The boundary line is solid. Crooked looking line, but anyway. And less than, so we're going to arrow down below here. Next, to use a red one, we have y is equal to and greater than 1/2 x plus 6. We go up here to our y-intercept of 6. Then we go up 1 over 2. And in the other direction. So this is what that one looks like. And it's greater than. So now we have the blue line shaded below the blue line. That's going to be, so we have our solution set up here for just this red equation or inequality. And then we have below the line. And so do we have any points that satisfy both of these inequalities? No. We will say no points satisfy both inequalities. So there we say our answer for this one is no solutions. No solutions for this one. That's okay. The last one we'll be doing in this set is when we have 3 inequalities. We have x is not equal to, but greater than 3. And what that is, that's an x equals inequality. And so I'm going to go get this blue. And we have x equals 3 is right here, so we come like this. So that's it, x equals 3. Right here. A vertical line. And greater than is going to be to the right. So I'm going to just arrow to the right of here. I'm going to write the x greater than 3. Okay, y is equal to and greater than -2. So I'm going to go get a solid red line, and -2 is right here. So y greater than and equal to -2, so we're going to go up like this. So that'll be y equal to greater than -2. And we have a third inequality. Make that color coded in green. We have x plus y is less than, not equal to, and less than 6. So we subtract x. So we have y is not equal to but less than -x plus 6. And for that we go to the y-intercept of 6, and we have -x. So that is going to be a less than, so that's a dashed line. So we come here, it's negative, negative, negative. So it's just dashed line like this. And we're going to shade which direction? Below. Okay, so we shade below here. And there it is. So here's the shaded below. And so the only area that seems to be common to all this is this little patch right here, because we're up above there, we're to the right of that, we're below that. And so we have very, very small area to work with here. So we'd have like 4, 0 would be a solution. And to get one more, gosh, I guess we could have 4, -2 right here would be in the solution set. And then really that's it. I want to go do one more thing to show you how you can graph this on the calculator, number 9. So I go to y equals, and we have number 9 less than or equal to 1/2 x. So 0.5x is the TI 84 CE calculator. And then we can come over to the left and put in this equal sign. We can actually change that. I'm not sure where we do that here. Well, it can be done. Let me see. I don't see, but we can actually draw that. Then we have 0.5x plus 6. So we have these two graphs right here. You can see them, and so we are between these two lines would be our solution set. Well, I hope this has been helpful to you. Good luck, and thanks for viewing.